Hello, oceanography students. So we are now going to discuss the sediments that you can find in the ocean. So let's start out by talking about what's on the seafloor. So what's on the bottom of the ocean? So first, the deepest you're going to have is crust, which is the hardest substance on the seafloor. And that can be made up of either oceanic crust or continental crust. And then on top of that, you have sediment. So continental crust tends to be mostly granite. Oceanic crust is basalt, which is also what you would find someplace where you had a volcanic eruption. Now, sediment is defined as particles of organic or inorganic matter that accumulate in a loose, unconsolidated form. So, essentially dirt that you see, sand that you see, those are all examples of sediment. And organic versus inorganic, organic means it came from carbon sources that were living. So we have, shells and things like that. Inorganic is rocks that have been weathered away. So you can categorize sediment by the size of the individual particles. So boulders would be bigger than cobble, and cobble would be bigger than pebbles, and pebbles would be bigger than granules. And we would call all of those gravel. And then you have another category that you can call sand, and that's between grain sizes of 2 millimeters and 0.0625 millimeters. And then the third category is mud. So this is the very fine stuff. Silt and clay, just like what you might sculpt out of. You can also categorize it based on where it comes from. What is the source of the sediment? So lithogenous sediment comes from land, comes from hard rocks that weather away. Biogenous sediment comes from living things, and hydrogenous sediment comes from chemical processes from water, which we'll discuss in more detail in a little bit. So let's start out with lithogenous sediment. And what we find on continental margins is mostly lithogenous sediment, because lithogenous sediment comes from the land, right? So anything the closest to the land you are, you're going to find sediment that's made up of the rocks that are along land that have been eroded away and broken down into smaller and smaller particles. Usually it's rich in quartz, and sometimes you can also find shells and the remains of dead organisms in the sediments that are found along continental margins, and so we would say that there is biogenous sediment mixed in. But for the most part, when you're looking at the continental margins, the area of the shoreline and going farther out, just a little ways up to the shelf break and such, you're going to mostly find lithogenous sediment. So how does lithogenous sediment get into the ocean, right? If the continental margins are dominated by it, which seems very obvious because it's coming from land, we also find lithogenous sediment out in the middle of the ocean, though. So how does it get there? Okay. So lithogenous sediment is transported by rivers, by glaciers, by wind, by landslides, and by volcanoes. So one way that they're transported is by rivers. So each year, rivers carry about 20 billion tons of sediment to the oceans. And usually that's coming from estuaries, from places where you have rivers coming out. And so you can see in this image here, this river coming out and this white color in the ocean. So this blue would all be ocean or water. And this white is actually the sediment that has been distributed by this river. Okay, so the river is flowing and it's bringing with it particles from land, and it is basically putting all those particles out into this estuary, or this semi-enclosed body of water that attaches to the ocean. Okay, another way that lithogenous sediment can be transported is by way of glaciers. So when glaciers freeze, when glaciers form, they actually crack the rocks that are along the surface of that glacier. And in doing that, the rock basically becomes part of that glacier, part of the ice. And when the glacier then starts to melt, lots of times glaciers melt from the bottom, which is called subglacial water. And that's where all the rocks are. So as it's melting, you can think of kind of like an under the glacier kind of river flowing, and that river is then bringing with it the rocks, right? But it's not exactly a river, it's actually the glacier that's just melting. The third way, which I actually think is the most interesting, is wind. And the reason why I think it's interesting is because wind can carry sediment so far. So this isn't going to be, this is not going to be gravel. It's not going to be boulders. It's not going to be bigger sized sediment. But the finer sediment can be carried completely across ocean basins. So you can actually find dust that comes from the Sahara in the Caribbean. So that's all the way on the other side of the Atlantic Ocean. And even more amazing, you can find dust from the Gobi Desert in the western United States. So that's over the whole Pacific Ocean. And it's getting there by way of just the wind. The fourth way would be landslides. And so landslides are basically going to put the lithogenous sediment out into the continental shelf. So, landslides basically mean where you have rocks that erode due to gravity or due to water, and it's already in a steep area, and those rocks basically erode and fall down and break up, and they end up in the continental shelf. And then finally, volcanoes can also distribute lithogenous sediment. So when a volcano erupts, it's putting ash into the air, which is then brought into, basically it falls into the ocean. And there was a volcanic eruption in 2010 in Iceland that put so much ash into the sky that it made it so that planes couldn't even fly. Okay, let's talk about biogenous sediment now. So biogenous sediment is what you find in the deep ocean. Because, you're going to find lithogenous sediment there too. Fine grains, which has been transported by wind or by way of volcanoes also sometimes. But biogenous sediment can also be found there as well. And biogenous sediment is made up of the remains of living organisms. Now, if you go to the beach, you pull up a scoop of sand, most likely you might find some little shell fragments in there, right? So those shell fragments would be considered biogenous sediment. But when we're talking about out in the deep ocean, we're usually not talking about those big sized grains. Instead, we're talking about like very, very fine silt, which actually comes from living things. So it's composed of silica and calcium carbonate because those are the compounds that make the outer casing of tiny little organisms called phytoplankton. And phytoplankton are organisms that are really tiny, and they just float around the ocean, and they can photosynthesize. So they end up being at the base of our food chain, which helps everything else to live. So if we look at this map here, we can see that all of the continents are in this tannish color, and then the turquoise and the gray and the blue, these all represent different types of sediment in the water, and the orange as well. So what we're talking about when we're talking about biogenous sediment, we're talking about this, the blue one that looks like bricks and the turquoise one, right? So you can also see clay there, which has been distributed by the wind, and that clay is lithogenous. But we also have these, what we call calcareous ooze and siliceous ooze. And the reason why we call it that is because it's so fine that when it's disturbed, it sort of oozes. It has like the appearance of something oozing into the water instead of like a dust. That you would see, normally what you would expect. So where do these sediments come from? Well, like I said, they come from types of phytoplankton. So silica deposits come from organisms such as diatoms and radiolarians, mostly diatoms, because diatoms are actually the most productive phytoplankton in most of the world's oceans. And both of these make their outer hard casings, which is what you're looking at here, out of silica. So when those organisms die, their bodies break down and they sink to the bottom and they eventually accumulate. calcium carbonate deposits come from organisms such as coccolithophores or foraminifera that make their outer casings out of calcium carbonate. You know what else makes their outer casing out of calcium carbonate? Clams and oysters. So things that you're most familiar with. Now, the thing about biogenous sediment is that it's whether or not it accumulates is based on a couple of different factors. One of them is dilution. So sediment is dominated by other types of deposits rather than biogenous. So like when we're talking about a beach that has a bunch of lithogenous sand with biogenous shells inside, it's mostly made up of lithogenous. So that's why we define it that way, even though there is some biogenous. So if the biogenous sediment is diluted by something else, then that would mean it's not really dominating that area. Productivity is another one. Since biogenous sediment comes from living things, how productive that area is, or how many organisms are in the water column, and how fast they're reproducing or turning new organisms out will tell you whether or not you're going to have a lot of biogenous sediment accumulating in that area. So if you have a lot of organisms, that means that a lot of organisms are dying at the same time, and you end up with a lot of biogenous sediment from the leftover hard parts of those organisms. And then finally is destruction. So seawater can actually dissolve these hard parts, and whether or not they dissolve depends on the depth of the water. So we're looking here at an image of an ocean. Okay, here's the sea floor, and we've got these little dots up here in the surface area because that's where photosynthesis is going to occur, because that's where the sunlight is. These little dots represent the phytoplankton, or the little organisms that usually lend to the accumulation of biogenous sediment out in the open oceans. So over here, there are not a lot of little dots, which means that that's a low productivity environment. Whereas over here, there are a lot of little dots, which means that that's a highly productive environment. And then over here again, low productivity. So when there aren't a lot of them sinking down, therefore, when you look at the sea floor in that area, you're not going to find much biogenous sediment there. Whereas over here, you have a lot of them, and therefore when they sink down, you will tend to have some of that accumulating. Now, this also depends on how deep the water is and whether or not those hard parts are actually getting dissolved into the water. So what does it mean for something to dissolve? When you put sugar in your coffee, remember, before you put the sugar in, you can see it. It looks like grains. You put in the coffee, you stir it up, and you no longer see it. It has dissolved into the water. So that's what we mean. If something has dissolved into the water, it has become part of the water. If something is actually piling up, if sediment is piling up, then it is not part of the water. It has not dissolved. Okay? So if water is undersaturated, which means that it doesn't have a lot of that chemical in it, then the chemical will dissolve into the water because the water can dissolve it because it doesn't have very much of it yet, right? So if you put some sugar in your coffee and you stirred it up, the sugar dissolves. But if you kept on putting more and more and more and more and more in, eventually you would start to see the sugar pile up on the bottom because the coffee would become saturated with the sugar and wouldn't be able to dissolve any more sugar, okay? So the seawater is actually undersaturated with silica at all depths, which means that unless there's a lot of organisms in that environment that make their shells out of silica, then the silica is not going to end up piling up. So productivity is a big one for that one. Now with calcium carbonate, it actually depends on the depth of the water. Seawater is saturated with calcium carbonate in warm surface water. So remember, calcium carbonate is coming from organisms that are called coccolithophores or foraminiferans, or shelled organisms that we think of like oysters and clams. So in warm surface waters, the seawater is saturated with it, which means that it's not going to dissolve it as well. But in the deeper waters where it's very cold, and the water tends to be more acidic or lower in pH. The pressure is high, there's more carbon dioxide down there. All of these factors contribute to the calcium carbonate becoming dissolved. And if it becomes dissolved, then it becomes part of the water and therefore it doesn't accumulate. So if you are at a location in the ocean that is very deep, then it's less likely for calcium carbonate to accumulate on the bottom unless there's a lot of it in that area, meaning that there are a lot of those tiny little organisms at the surface. So how deep you can go and not have the calcium carbonate dissolve, we have two different definitions of depths. So one is called the lysocline. So that's the depth at which the pressure and the CO2 are high enough to begin dissolving calcium carbonate. So as that, tiny little shell, dead shelled organism sinks down, it eventually gets to the lysocline, which is about 4 kilometers deep. And that's where that hard body will start to dissolve. It'll dissolve fairly slowly. So if the bottom of the ocean is right about at the lysocline, then you might have an accumulation of calcium carbonate sediments on the bottom if you have a lot at the surface. But if the water is deeper than 4.5 kilometers, which is where the CCD or calcite or carbonate compensation depth is, if the depth of the water is deeper than that, then that calcium carbonate body is going to dissolve into the water very quickly. It can actually dissolve within 2 days and not be there anymore, okay? So let's look at a little image to try to figure this out, okay? All right, so here is an ocean, right? Let's say that there are organisms in the surface waters that make their bodies out of calcium carbonate. So here is the lysocline, all right? So this is the point at which the calcite starts dissolving, but it dissolves fairly slowly. This line here, let's say that this is the CCD or the calcite compensation depth. At this point, when the dead body of that shelled organism gets down there, it will dissolve very quickly, okay? So if the seafloor is down below the CCD, then it's unlikely that you're going to find a lot of sediment that's made out of calcium carbonate there, because the calcium carbonate will dissolve into the water and not pile up. So it's like when you put just a little bit of sugar in your coffee and it dissolves. Okay, so it doesn't pile up. But if the depth of the water, let's say the depth of the water is just above the lysocline, right? So ignore everything down here. There's no water down here. The bottom is right here, is right above the lysocline. It hasn't, so therefore that dead-bodied organism, the organism's dead body is not going to sink below where dissolving happens. So if the bottom is right here, you're going to find an accumulation of calcium carbonate. But if the bottom is down deeper, then you're not going to see that. So up here, this would be like when you pour lots and lots of sugar into your coffee and it piles up. That's what we would expect if the depth of the water was shallow up here. Okay? And finally, our other spot in the ocean is the mid-ocean ridge. So what kind of sediment might we find along the mid-ocean ridge? Well, we already learned that you can find lithogenous sediment all over the ocean. You could also find biogenous sediment accumulating because mid-ocean ridges tend to be more shallow, because you've got, remember, it's kind of like an underwater mountain chain, right? So because it's shallower, that means that it's usually above the CCD depth, and therefore the biogenous sediment is not going to dissolve as rapidly or at all. So you can find it there, but then there's another type of sediment that you can find along hydrothermal vents that is very specific to those hydrothermal vents. It's called hydrogenous sediment. And this is a little bit more confusing. But basically what happens is, you previously learned about hydrothermal vents, right? You've got water that is along the seafloor that seeps into the seafloor. And because the seafloor is hot, that water can then dissolve the minerals that are in the seafloor. And so the water now has these minerals dissolved in it. It's really hot, and eventually it bubbles up and it comes back out into the cold ocean. And when it comes into the cold ocean, those materials that were dissolved, they harden and they form hydrogenous sediment. Okay, so dissolved materials in water come out of solution or precipitate due to a change in conditions. Right? So the water seeps down into the seafloor. It gets hot because the seafloor ends up being hot around hydrothermal vents, and it then dissolves minerals. It travels along, and then it bubbles out back into the cold ocean. And because of the change in the temperature from being hot allows it to dissolve, like compare trying to put sugar into your hot tea versus your cold tea, right? When it's hot, the sugar dissolves very easily. When it is cold, the sugar doesn't dissolve very easily. This is the same thing that happens here. So you've got water seeping down into the seafloor. It dissolves the sediment that's there, the sediments and the rocks that are in the seafloor. And then it bubbles up into the cold water, and those sediments then harden back out. And they create these really cool hydrothermal vent chimneys, or basically piles of hydrogenous sediment that has come out where the water is seeping out from the seafloor. Okay, please let me know if you have any questions, and you can post questions in the weekly discussion. I don't get to them as quickly as if you just email me, though. So if you have a question that you want answered fairly quickly, then send me an email and ask me, okay? So for this week's discussion, please answer the following questions. 1, is the deepest spot in the ocean in the very center of the ocean? And explain your answer. 2, if the seafloor is deeper than the CCD, would you expect to find sediment made of calcium carbonate piling up there? Explain your answer. Okay, I hope you have a good day or night. I'll see you soon.